All right, let's talk about one of the biggest questions in all of comic book lore, something that's actually sparked a real debate between actual scientists. The question is, just how much does Thor's hammer, Mjolnir, really weigh? I mean, is this thing an immovable object, or is there something else going on?
Okay, so let's break this down. In one corner, you've got the one and only Neil deGrasse Tyson. He did the math and said the hammer is as heavy as a herd of 300 billion elephants. Yeah, you heard that right. But then, in the other corner, you have the official word from Marvel itself, from an old trading card, no less, that says it's exactly 42.3 pounds. So, who are you going to believe? The world-famous astrophysicist or the people who created the character?
And believe it or not, this isn't just a bunch of fans arguing online. This has led to a real, friendly scientific showdown between Neil deGrasse Tyson and a material scientist named Suveen Methadou. And what's so cool is that they both use science to argue their point, but they start from completely different places.
So to get to the bottom of this, we've got to unpack the actual science behind each claim. And we're going to start with Dr. Tyson's side of things, his theory about a ridiculously heavy hammer. The whole thing really boils down to one key piece of comic book lore about where Mjolnir came from. See, Tyson's whole calculation is based on the legend that Mjolnir was made of neutron star material. Now this stuff, it's what's left behind when a gigantic star dies and collapses in on itself. And it is, no joke, one of the densest things in the entire known universe. Just to give you an idea of how dense we're talking, a single sugar cube's worth of this neutron star stuff would weigh as much as a mountain. A mountain! So if Mjolnir was actually made of this material, it wouldn't just be heavy, it would be, well, basically infinitely heavy from our perspective. And suddenly, that whole 300 billion elephants thing starts to sound a little less crazy, right?
But, and this is a big but, here comes the counter-argument from Suveen Methadou. He says Tyson made one tiny but absolutely critical mistake. The comics say Mjolnir is made from a fictional metal called Uru. And here's the key. It was forged in the core of a dying star, not made of the star itself. That is a huge difference. Think about it. It's like the difference between baking a cake in an oven versus trying to make a cake out of the oven. Two very different things.
So that brings us right back to our big question. Is this hammer unimaginably heavy, or is it actually, at just over 42 pounds, impossibly light for its size? I mean, that would make it lighter than aluminum. And you know what? This fun little fictional puzzle is the perfect springboard into a really fascinating and very real area of physics.
So let's just forget about magic hammers for a second and bring this down to earth. The whole idea behind Mjolnir is that only the worthy can lift it, right? Which implies some kind of mastery over its own gravity or mass. And that gets you thinking, is there any science we know of that could, even theoretically, let us mess with gravity?
Well, believe it or not, the answer starts with Albert Einstein. His theory of general relativity says that huge, spinning things, like planets and stars, don't just exist in space-time. They actually twist it. They drag the very fabric of the universe around with them as they spin. This whole effect has a pretty cool name, gravitomagnetism. And it's actually a great way to think about it. You know how a moving electric charge, like electricity in a wire, creates a magnetic field around it? Well, the theory goes that a moving or spinning mass creates a gravitomagnetic field. It's almost like gravity has this hidden magnetic cousin.
And this effect, which scientists often call frame dragging, isn't just some sci-fi idea. It's a real, physical thing that's supposedly happening all around us. Our own planet, spinning on its axis, is supposedly dragging space-time along with it. We've even built incredibly sensitive experiments to try and actually measure this tiny, tiny twist.
And this is where you start to see the problem. NASA's Gravity Probe B was this amazing, super sophisticated satellite built for one purpose, to measure this effect from Earth's rotation. And the amount of twist they were looking for? A ridiculously small 0.042 arcseconds per year. To put that into perspective for you, that's like trying to measure the width of a single human hair from a quarter of a mile away. So yeah, frame dragging is real, but man, is it weak.
Okay, so of course that leads to the very next question. If this force is real, can we, use it? Could we somehow amplify it and create some kind of anti-gravity drive? A whole new way to travel through space?
And you might be surprised to hear that the world's biggest space agencies have absolutely taken this seriously. Back in the late 90s, NASA actually had a program called the Breakthrough Propulsion Physics Program just to look into these kinds of wild ideas. A few years later, the European Space Agency funded its own big study, and for years there have been these controversial, kind of fringe claims about being able to create gravity shields using really exotic materials.
Yeah, a lot of this research focused on materials like superconductors. The most famous, and let's be honest, most controversial claim came from a researcher named Eugene Podkletnov. He said he measured a gravity shielding effect right above a spinning superconductor. Now that got a lot of people excited. The images you're looking at here are from a real NASA paper and a diagram for an experiment trying to see if these claims were real, if you could actually create and measure a tiny shift in an object's mass in a lab. So after all of that research, all that hope, what was the final word? Well, this quote from that big European Space Agency study really says it all. They concluded that, even if gravity could be controlled, influence on spacecraft propulsion would be quite modest and would not lead to breakthroughs. In other words, a big letdown.
So at the end of the day, based on everything we know about physics right now, there's just no way to generate a gravitomagnetic field that's strong enough to lift a hammer, let alone a whole spaceship. The forces are real, absolutely, but they're just way, way too weak to start a propulsion revolution.
So where does all this leave us? We started by asking how much a magic hammer weighs, we took a deep dive into the very edges of real-world physics, and we kind of found out that the magic of Mjolnir isn't something we can build. And maybe that's because we've been asking the wrong question the whole time.
Think about it. The real secret to Mjolnir has nothing to do with neutron stars or fictional metals. If you've ever read the comics or watched the movies, you know the answer. The hammer's power comes from that famous enchantment, "Whosoever holds this hammer, if he be worthy, shall possess the power of Thor." It was never about the weight. It's all about being worthy.
And that, right there, is just a beautiful parallel to our own world, isn't it? We don't have any magic spells that can just grant us ultimate knowledge or power. For us, the magic is the slow, hard, sometimes really frustrating work of science. It's proposing ideas, building these incredible experiments like Gravity Probe B, and just slowly, piece by tiny piece, uncovering the secrets of our universe.
So in the end, it really doesn't matter if Mjolnir weighs 42 pounds or 300 billion elephants. The real story isn't about physical weight, it's about something more. And for us, that something more is knowledge. The journey to earn that knowledge, to prove ourselves worthy of it, well, that's the greatest adventure of all. So the question is, what deep truths about the universe are we going to be worthy of discovering next? Thanks for joining me.